Okay, so good morning once again, guys, gentlemen. We're going to do binary logistic regression. Last meeting, what we did was a multiple linear regression, and we learned how to model a data, regress a particular variable, and then we learned that in it's good not to use all the data, but to split it so that we have a training data and a testing data. So from here on, guys, that's our methodology. And there are several ways to split your data. I think last time also we looked at the k-fold cross-validation. Okay. Today we're going to also split our data. So first, let's understand. Uh, it's always good practice, guys, to get your working directory and then set your working directory. So you may wish to follow along. First, I'm going to get my working directory. I'm going to see where my default working directory is. We discussed this before naman, di ba? Yung
Yes po.
I think so.
Yung first meeting.
Get ng working directory at saka set ng working directory. So, yeah. So, sa akin nasa, okay. Kasi sinet ko na kanina, no? So it's under the folder R projects, and then under that folder there's this yung folder natin MCF302. So kayo guys, kung ano yung ano nyo, kung saan yung working directory nyo, you may change the working directory, di ba? You may change it by setting the working directory. And last time we learned how to set the working directory. You just go to the folder of your choice and then copy the path. For example, let me see this one. Okay. So this one, I'm going to use this. Ito. I'm going to use this as my working directory. So what I did was go to this folder and then, di ba yung copy path na to, di ba? If you recall right, guys?
Yes, sir.
Copy path. And then I paste it here in R. Here. Control V. Only that, ayaw ni R yung naka-forward slash ito. Okay. Forward slash. So, nalito ako. Backwards. Yeah, this is, ayaw ni R ng backward slash, no? Ang gusto niya, forward. Baliktad. Nalito ako sa backward at sa forward. So, ano ba to, guys? Forward slash to, di ba?
Yes po.
I'm not sure.
Anyway, sige. Let's experiment. Experiment natin. So, set working directory. Kung yan kasi ang gagamitin mo, okay, I'm going to run this, no? I'm going to run this particular code. Okay, mag-error siya, no? Ayaw niya yung backward slash. So this is backward slash. So you have to convert this into, kasi pag kinapit path mo sa Windows, sa Microsoft, ang pag-copy path niya, ang ginagamit niya yung backward slash ito. So what I want is, I'm going to highlight this and then Control F. Control F, so lalabas dito yan, dito. Copy paste yun, di ba? Find, Control F. And then I'm going to find yung backward. And then I'm going to replace it with forward slash. Yan. You see this, guys? I'm going to replace the backward slash with forward slash. So, hinanap niya, no? Ito yung unang nakita niya. And then just replace it. Replace, replace, replace. It will look for the backward slash. Okay. Replace, replace, replace. Okay, tapos na, no? Kaso, mali naman yung kinap niya na ano. Sandali. Mali itong, this is not the site that I want. This is not the folder that I want. So gusto ko dito. Saan yun? Dapat dito. Now, copy path. Balikan ko to. Yan, okay. So, correct na to, no? Users, sa ano ka, sa machine ko, our projects and then this subject. Then let me replace itong mga backward slash. So, Control F. Dito, dapat ang kinapi ko lang to. Control F. Yan. This one, I'm going to replace it with forward slash. Replace, 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 replace. Okay, so okay na. No? Alright, so naka-forward slash na siya. So let me run this. Okay, so nagpalit na ng napalitan na yung ng working directory ko. And I'd like to check that dito na lang sa console, get working directory. Get working directory. Okay. So it should now reflect this one. Yan. Users. Okay, bakit hindi? Hindi lang ha. Minsan nagkaroon ng problema eh. Get working directory ito. It already changed the working directory. Set that working directory, okay? Then get WD. Oh, problema. Kayo guys, napalitan na
Nag-error din po yung sa akin.
Sa get working directory.
Pag nag-set ako ng working directory.
Okay na ako. Okay na ako.
Feeling ko dahil may space po yung yung pinagsasavean ko.
Subukan mo siya i-run dito sa script window kasi dito sa nung dinarun ko siya sa console hindi nga nakukuha eh. Ewan ko kung if that's the reason. No? Pero dito sa sa script window, okay na siya. Okay. Anyway guys, ano lang naman yan, that's because sometimes nagdi-default si R minsan sa sa isang directory kung saan mo sinave yung yung R, no? But sometimes you don't want that to be your working directory. You want your working directory to be in a specified folder. So that's how you do it. And the advantage of doing that is when you're accessing files, kunyari ito, I'm creating now an object called that. We're creating an object called that. And then we're using this kasi CSV yung file na gagamitin natin. Read that CSV. And then, yung file, sasabihin ko lang kung ano yung file na yun. No? That file should be in your working directory. No? So, here, in my case, okay, sa loob ng working directory, andyan yan si binary.csv. So, when we access that file, okay, so, na lang, read that CSV na lang, read that XLSS, depende sa file, and then just identify the name of the file. Okay, so that will hindi natin kailangan i-import dataset. Okay, so that's just one way. But of course, guys, if you don't like to do this, then you can just use the old and reliable import dataset. No problem with that. Okay, so we're just looking at different ways in order to access our data. First, you have to know where your working directory is, and then set it to a location which you want to be your working directory. And in that directory, in that folder, you put your data, and then you can just read that data. Okay, so let's read that, guys. That binary.csv. Okay, so that binary CSV should appear here. Sorry, marami akong nga pala. Marami na akong nakalagay dito na. Okay. just erase this first. Yes. Okay. So feedback, guys, were you able to access this binary.csv, which we're calling that data?
Yes, sir.
Okay, and if we, guys, alam niyo naman kapag view natin yan, it will appear. Say tab here. So, papakita sa atin yung spreadsheet niya. Okay, so this is quite a simple data. This will just allow us to review what the concept of logistic regression is. Did you have, guys, by the way, did you have exercises on logistic regression before?
Wala po ata.
Wala. William, ikaw?
Parang hindi rin, sir.
Hindi rin. Okay, sige. So, it's important, guys, as finance people, for us to know what logistic regression is. Ang difference sa multiple linear regression is that the dependent variable that we're trying to explain or understand or predict in a multiple linear regression, it's a continuous variable. In a logistic regression, the variable of interest, our response variable, our predicted variable is a binary variable. Okay, so it's a variable, binary sa 0 or 1. Okay, so let's go back.
Ay, may mga dummy. Dummy variable.
0 or 1 yung ano.
Naalala ko po, meron.
0 or 1 lang. Siguro meron kayo nun. Medyo nakalimutan siguro. No?
Meron po. Gumamit po kami ng dummy variable dati.
Iba yung dummy variable, Dummy variable.
Yung pinalitan po kasi na,
sige.
parang, ang ginawa po kasi namin nun, yung parang, yung yes or no, pinalitan namin ng 0 and 1.
Okay. But that can be, that's not necessarily logistic regression. Yung logistic regression, yung outcome variable natin, yung dependent variable, siya yung dummy. Kasi baka yung ginawa yung dummy is just an independent variable. If it's an independent variable, that's not logistic regression. But if you are modeling a variable in the dependent variable which you converted into 0 or 1, yun ang logistic regression. Okay, so malamang most probably you did that. Okay, so let's just understand the structure. Okay, yung structure natin, so ito, si admit integer. Okay, so si admit, guys, 0 or 1. 0 or 1 siya. So binary to, Tapos si GRE, GPA, tsaka si rank integer din, 3, 1, 4, 2. Okay, so itong data na to, guys, this is a data of a certain university of 400 students which applied for entrance to that university. 0 means natanggap ng student, 1 means the student was not accepted. Okay, and then these are measures of GRE. It's I forget the meaning of GRE, but it's it's like It's like a parang siya, measure ng ano ba yung mga
Parang IQ.
IQ, gano'n, oo. Di ba may mga GMAT, mga etc., mga measures that's used. GRE is one of them. And the GPA, grade point average nung high school niya, okay? And then rank is to categorize kung anong high school siya galing. Pag 1, that means a very good school. Pag 2, good school. Pag 3, average lang, and 4 siguro. So they categorize the high school, the secondary school from where the student came from. And then here we're going to create a model by which we will predict if a student will be accepted or not accepted into the university. So ganun, guys, yung logistic regression. So ginagamit ko, for example, magde-default sa finance, kunyari, a person is applying for a loan. So based on certain parameters, you can predict whether that person will default or not default on his loan, or sa corporate setting, magiging bankrupt ba tong company na to or not bankrupt. Okay, or sa medicine, for example, based on certain parameters like weight, height, tapos kung non-smoker ba siya, smoker, okay, then we can predict whether that person will suffer from stroke or not suffer from stroke. So mga ganon. Basta ang dependent variable natin, ang outcome variable natin, can be answered by yes or no, 0 or 1, binary yun. And then we use logistic regression for that. Okay, so
Sir,
yes, yes.
anong difference ng logistic regression sa discriminant analysis?
Ano ba yung discriminant analysis? Yung discriminant analysis, ang ginagawa natin dyan, parang PCA siya, yung principal component analysis. Yung hahanapin natin kung ano yung mga ano yung mga variables na pwede natin gamitin. So, parang dinidiscriminate natin yung yung mga variables. Clear ba yun? In a nutshell. Kung gusto nyo, pwede tayo mag-example ng di ba nag-multivariate analysis kayo?
Yes po, yung
Yes,
ginawa, yung project ko kasi dun, yung ginawa ko po kasing project dun, parang yung predictability ng bankruptcy.
Okay.
Tapos naalala ko lang nung sinabi niyo, yun nga, sa bankruptcy.
Oh, interesting. Predictability ng bankruptcy. Ang ginamit mo, MDA, multiple. Okay. Siguro ang assignment mo sa next meeting, i-share mo sa amin yun in R. Anong ginamit mo, software?
Statistika po.
Statistika. That can be done also in R. Siguro, if you want, magkaroon tayo ng isang example ng ganyan. PCA, Principal Component Analysis, Cluster Analysis,
Cluster analysis.
mga dinis kasi yun sa di ba? Sa multivariate. Pero guys, ang dali yan sa maganda sa R yan, yung mga ganyan. Pero siguro, mag-machine learning muna tayo, tapos siguro, idagdag natin yan para makita nyo lang yung for you to be able to see how that can also be done in R. By this time, I hope I have already convinced you that R is the way to go. I'm not putting down Statistica. Statistica has its, yun din yung ginagamit ko dati. Statistica has its strengths, pero iba talaga ang R. Una, sabi nga natin, kasi ang R, it's a robust software, kasi it keeps on growing, ang dami-daming tapos free pa siya. Ang dami-daming mga packages na dinadagdag sa kanya, ina-update, dagdag ng dagdag. I'm not sure if Statistica has now yung mga neural networks. I'm not sure. Baka nag-update
po siya yung
Oo naman. Oo, syempre.
Sa workplace, mas madidinig mo yung R
Yes.
compared sa statistics.
Correct. Okay, so let's proceed. Now, so what are we going to do today? What we're going to do is, so let me just flash this. We would like to predict yung admission sa isang university based on these three parameters. GRE, GPA, and rank. And we will see kung how good our model is in predicting yung admission. We have 400 observations, 400 yung sample size natin. But once again guys, hindi natin gagamitin yung lahat ng 400 to predict the outcome. We will split the data into training and then testing. And then titingnan natin kung yung data natin mag-work dun sa unobserved na values. Yung unseen. When I say unseen, yung in-split natin yung data natin ng 400, gumamit tayo ng a certain sample of that. Okay? Minodel natin, and then gagamitin natin yung model natin dun sa hindi natin ginamit na data. Okay? And that's the way to go. All right. We have to convert si admit at saka si rank. Kasi si rank hindi naman categorical variable yan, di ba? So it can be used to classify your observation into 1, 2, 3, 4. As I said, 1 being the top rank institution. So siguro yung university nito, ang ginawa niya, classify niya yung mga high schools, yung mga secondary level schools where the student came from into 1, 2, 3, 4, and see if that has any bearing on whether that student will be admitted or not. Okay, so let's run this. Run natin itong, di ba, ang pag-ano yan guys, yung variable natin, yung object natin and the specific variable, we're converting it as a factor. Okay, so as that factor, yung variable of interest natin. Okay, so let's do this for both admit and rank. Okay, and if we check, guys, the structure, let's see, dito ko na lang check. Structure yung data natin, structure ng that. Okay, we can see now that admit is already a factor, GRE is integer, GPA is numerical, and rank is already a factor. Okay, so are we able to follow, guys?
Yes, sir.
Okay.
Yes, sir.
Now, a very quick classification lang. Tingnan natin, guys, kung we can use the function x tabs. This is from base R, cross tabulation po, no? Where we'd like to plot admit. So this will be your dependent variable. And this will be on your y-axis and your rank on the x-axis. So ito, pinaplot natin, cross tabulation, yung admit at saka yung rank. Inuna natin yung dependent variable, so this will appear on the y-axis, and then yung rank on the x-axis. And data natin that. So let's see. Nagrana sa inyo, guys?
Yes,
po.
sir.
Bilis sa inyo, no? Sa akin, nagkakaproblema tong machine ko.
Sir, kailangan na ata nung bago.
Oo. Oo nga, dapat lang talaga. Ano kasi ito desktop to hindi ko ginagamit yung laptop ko. Ayan, tingnan mo, tagal Ano ba yan?
Naset ko na yung working directory.
Oo na, magaling ka.
Gumana na din po.
Saan mo rin sa console o sa ano?
Sa console po. Ay,
Ganun.
gumana sa
Uy, ano ka ba? Ayaw mong tumakbo.
Ay, baka hindi na, sir.
Ha?
Parang hindi na nag-register.
Hindi nga nagrarun.
Hindi lumabas yung code doon sa console.
Sa taas.
Oo nga, hindi nga Hindi dapat lalabas dito yun. Pero nag-run ako kanina Okay, di ba? Inan natin. Yan.
Pero yung sa text.
Yan, tagal Tagal lang talaga niya.
Oh.
Ayan, wait. Error pa.
Ayan.
Yan, tumakbo na.
Okay,
Ilang beses tumakbo. Ano lang, ang inaano
Oh,
lang,
wow.
sinasabihan lang ako ng na patience lang.
Like, ang dami, sir.
Oo nga, tatlong beses kong ginawa Okay, so what does this tell us? This is cross tabulation, no? Admit 0 means hindi siya na-admit, 1 na-admit siya, no? So those who were not admitted in the rank 1 school were 28 out of 33. So medyo mataas yung batting average ng rank 1 na school, more than 50%. Si rank 2 naman, yes?
Sir, question, hindi ba dapat out of 61?
Ano sinabi ko?
33.
No, sorry. You're correct. Galing. Actually, I was just testing you, no?
Ah.
Tama. Out of 61 to, no? Out of 61, what I meant was that 33 out of 61 yung natanggap. 28 lang yung hindi natanggap. What I meant was 28 yung hindi natanggap compared to 33. So mas marami natanggap, no? Unlike yung other schools, guys, si rank 2, 97 yung hindi natanggap, di ba? 54 lang yung natanggap. So mas this is just about one third, no? One third. We can actually put here the percentages, pero huwag na lang kasi that's not really our lalo na si rank 3 and rank 4. So you notice na mas malaki yung chance na to be admitted in the university if the student was coming from a rank 1 rank 1 tier school. Okay, so let's now guys split our data. You remember we used the sample before. Okay? Diba? So let's set the seed para pare-pareho tayo ng pag-split ng data. Let's set that seed. Okay, and then diba, if you recall guys yung sample, ano ginagawa ng sample? The sample function. Let's have a quick review. Sa akin, lumabas na yung help nyo?
Yes po.
Ayun, okay na.
Yan. Okay, so ito, random samples. This is natin kunin sa base, random samples and permutation. Okay, sample. Diba, sample takes a sample of the specified size from the elements of X using either with or without replacement. So you're drawing out a sample, specified natin yung size based on elements of your data. So ito yung ano niya, this is the syntax. Okay? So dito guys, ang gagawin natin dito, so andyan yung X, and then size, and then kung re-replace mo natin, and then yung probability. So sample, ano yung sample natin? We're going to generate two samples. Ano yung size? Yung size is the number of rows ng data natin. If I run this, for example, here, n row dot, this will give us yung 400. Kasi 400 yung 400 yung sample size natin. There. Diba? So sinasabi natin dito, draw out from 400, gawa ka ng dalawang samples, replace is equal to true, and then ang probability 0.8 and 0.2. So 80% at 20%. So let's run this first and see what happens. So we're creating an object called ind or index. No? So let's view index. Tingnan natin kung ano nangyari. Let's view ind. Okay. So, okay, what happened? Okay, gumawa siya ng sample, no? Gumawa siya ng isang index na 1112, 1112, okay? Ilan yan? 400 yan. So, we're going to adapt this index to our data. Diba yung dot natin na data, there are 400 observations. So, ibig sabihin, i-split natin yung data natin. Lahat ng 1 will go to the first data set, our training data set. Lahat ng 2 will go to our testing data set. Okay? So, we're randomly splitting our data. So, hindi natin ginawa na kunyari, 1 to 300 will be 1 to 300 will be for training, and 301 to 400 will be for testing. Okay, kasi remember I told you that the importance of this is that it will remove any bias, especially in the ordering. Kasi baka in-arrange na alphabetically or etc. So to remove that, to make sure that the sample for train and the testing are really random, then we created this index which splits our data. Okay, so na mag-create tayo ng train data set natin. Si train will be coming from that, and then we're going to subset it using ind. Diba? Itong ind natin, lahat ng ind is equal to 1, pupunta dun kay train, and lahat ng ind is equal to 2, pupunta kay test. Okay, so that's what this means. No? Again, guys, I'm creating an object called train, and where is this coming from? From the dot object. Okay, ano yung dot object natin? Yung original object natin. Ito. And then, ang mangyayari, guys, lahat ng number 1 dito sa index, yan, 1, 2, 3, 4, okay? pupunta kay train yan, si 5 pupunta kay test, etc. Okay, so let's run this. Okay, so meron na tayong train and testing. And notice guys, si train natin, 325. So si test natin is 75. This is 80%. No? 80% approximately, hindi siya exacto. No? 80% of 400, that's 320. So medyo may konting difference. No? So yes?
Restroom lang ako sa test.
Yeah. Yes, Cells? Si William pala. Sorry. William?
No.
Sorry.
Okay lang.
Celso, ano yung question mo? Naka-mute ka, Celso.
Ay. Baka na DC ulit siya, sir. Test.
Si Celso. Baka na naman, disconnect. Celso, are you there?
Pwede po.
Yeah. Okay. May question ka?
Wala pa.
Wala. Okay. Alright. So, we're na-create yun na guys yung train and tsaka testing data.
Yes, sir.
Po.
Okay, let's check the training data. If you take a look guys, 1, 2, 3, 4, tapos walang 5, di ba? 6, 7, 8, 9, 10, 11, 12, 13, walang 14. So yung mga observations na yun, napunta siya kay test. Kay test yan, 5, 14. So ito yung mga observation numbers, yung mga ID numbers na napunta kay testing data. Tapos yung the rest, napunta kay training data. So that's what happened guys, no? We were able to split the data into 2. And then ano yung objective natin? Kasi we don't want to do a modeling that's overfitted. Okay? Kasi kunyari yun yung data mo. Paano mo test yung data mo, di ba? Kung okay ba siya. Anong ginawa natin? Linagyan natin lahat ng observations natin doon. Okay? So mag-create siya ng model na specifically for all those observations. So the practice is to split your data. Tapos titingnan natin yung training data, i-run natin model natin doon. And then, titingnan natin guys if our model will work also in the testing data. So that our model is not overfitted. Okay. All right, so let's now, guys, let's now regress. Let's create this object called MyMod. And then this is, we're going to use LM. Diba? Ito yung ginagamit sa regression. Oo. And then, ang dependent variable natin, admit. And then we're going to predict admit using GRE plus GPA plus rank. Or you could have used admit and then tilde and then dot. Diba? Pareho lang yun.
All the variables.
All the variables. Pag ginamit natin dot niyan, so tatanggalin natin dapat lahat to. Okay, which means all the variables. Anyway, so alam naman natin yan. And then data is equal to, notice guys, training data gagamitin natin. Training data. Okay, so summary natin yung MyMod. No? Okay, when we run this guys, okay, what does it tell us? Okay, ano nangyari? Hindi niya rinan. Hindi niya rinan. Kasi, what's the why? What's the rational why it didn't run? Si LM guys, ginagamit lang yan when your dependent variable, when your response variable is continuous. Okay? Kaso si admit, hindi naman continuous yan. Factor yan di ba? It's a factor. In fact, ano value ni si train natin, 0 or 1 siya. No? So hindi siya, kung hindi natin ginawang factor to, okay, subukan lang na, wag na. Kung hindi natin ginawang factor siya guys, possible na mag-run kasi kasi siya, yung numerical. No?
Yeah.
But we converted it into a factor. That's why the LM will not work. So, for logistic guys, we will be using the GLM. Okay, check muna natin GLM. That's the generalized linear model.
Linear model.
Oh, generalized yan. Ginagamit yan sa lahat ng mga, for example, maraming possible na gamit ng GLM. No? Okay. So that's from the stats package, and we did not, there was no need to load this, yung library natin itong stats, kasi it already comes with base R. Okay, so GLM is used to fit generalized linear models, specified by giving a symbolic description of the linear predictor and a description of the error distribution. So ito importante dyan guys, yung family. No? Okay, so family, ano ba yung mga family dyan? Let's see. Okay, define ba dito yung family? Kasi iba-iba yung family, no? Pwedeng binomial, pwedeng Poisson, exponential. Saan ba siya? Sa explanation ng family. The family object was, you click this. Yan guys, no? Binomial, Gaussian, gamma, inverse, Poisson, quasi-binomial. So maraming pwede, no? Maraming pwede. So, but we're just going to use binomial. All right. So if you take a look at our function now, our code, so we're creating this object mod, and then we're using the GLM, and then admit regress on the three variables, GRE, GPA, and rank. Data is equal to train, and then we have to include this. Family is equal to binomial. Okay? Family is equal to binomial, which is going to use the logit function. Okay, so let's run this. Okay. So here now, guys, ito na yung result natin. No? Okay, yung deviance result, received was, ito yung parang error term siya. And then yung coefficients natin. Okay. So let me increase the width and then let me run this. Okay, so we noticed that GRE was not significant. Tapos sa mga rank may mga insignificant. No? GPA is significant. So GPA and rank were significant predictors, except that si rank 2, hindi siya significant in relation to rank 1. Okay, so we'll in a while we'll explain what these are. So,
Sir, question.
Yes, sure.
Sir, saan yung rank 1?
Remember guys, factor to, di ba?
Oh,
Diba naalala
so
niyo?
yung benchmark yung 1.
Oo, correct. So hindi niya pinapasok si rank 1 ngayon. So ang interpretation niya ni rank 2, rank 3, rank 4, it's always in relation to
Rank 1.
rank 1. Oo. So for example, if I interpret this, si rank 2, although hindi siya significant, but assuming na significant siya, so this means that rank 2 has 0.57 is 0.57 lower in terms of log odds ratio. Take note, ang ano dito ang dependent variable natin guys, hindi natin ini-interpret as in the same manner as sa multiple linear regression. Iba siya. I'll explain in a while, no? So ito si rank 3 is negative 0.112 log odds ratio in being admitted as compared to rank 1. So this tells us guys na sila rank 2, rank 3, rank 4, mas mababa yung log odds ratio nila. Or log odds ratio, which is a chance actually for them to be accepted relative to rank 1. Okay? But we don't interpret it in the same manner as do sa multiple linear regression. Okay. All right. Now, pwede natin isama dun sa output si rank 1, no? So how do you do that? Kasi dito guys, di ba? Notice na may intercept. Okay? And si intercept, guys, it has a bearing on the relationship between rank 1 and rank 2, rank 3, rank 4. In fact, guys, in fact,
Sir, question, sorry.
Yes, sure.
Is the intercept the same as yung parang base coefficient dun sa normal regression?
Yeah, in a sense. No? Kasi, ano ibig sabihin ng intercept dito? It means that all your variables are zero. So GRE is zero, GPA is zero, diba? Rank 2, 3, 4 are zero. So lalabas lang yan na -5, -5. Ito lang yung log odds ratio for rank 1. For an individual with 0 GRE, 0 GPA. Of course, rank 2 and 3 and 4 will not appear kasi rank 1 yung tinitingnan natin, di ba? Tama ba?
Yes, sir.
So ngayon,
sorry.
yes, kung rank 2 naman, guys, yes.
Sorry.
Yeah,
So
sure,
if
go
you're
ahead.
trying to, let's say if you're trying to predict manually, it's the same as regular regression, parang you'll substitute like the values.
Yes,
Let's
tama.
say if your GPA is 4, you'll multiply it still to the...
Yes, correct. Correct. Exactly. Okay. Thank you. So, paano natin i-interpret kunyari sa rank 2? So si rank 2, assuming this is significant, ang mangyayari, ano yung slope niya, ano yung intercept ni rank 2? Yung base, base value. So si rank 2, guys, ibig sabihin nun, kung wala siyang GRE, wala siyang GPA, 0 GRE, 0 GPA, it will have, the intercept for rank 2 will be -5 plus 0 plus 0 plus -0.57, diba? Plus 0 plus 0. Diba? Si rank 2 papasok kay rank 2. Right?
Yes.
Diba? So, consistent siya na rank 2 will be 0.57 less than rank 1. Kasi si rank 1, -5. Tapos si rank 2 naman, -5 plus -0.57. So, consistent pa rin yung interpretation nun. No? Right? So, if we're comparing for rank 2 and rank 1, individuals with no GREs and no GPAs, 0 GRE nila, 0 GPA, then rank 1 will have a log odds ratio that's -0.57 greater than rank 2. And what's that value? -5 plus -0.57. So si rank 2, -5.57. Si rank 3 naman, -5 plus -1.12. Si rank 4, -5 plus -1.53. Okay? Now, we can include rank 1 here. No? Pero ang gagawin natin, tatanggalin natin si intercept. And how do you do that? You do that by doing this. No? GLM pa rin, and then admit, no? Tilde, and then dot, use all the variables, and then -1. The -1 here indicates that you remove the intercept. So when we run this, M1, okay, ano nangyari? What happened, guys?
Rank 1.
Diba? Si rank 1, -5 pa rin. Si rank 2, diba, -5 plus yung -1. Yeah, yun. Yun ang nangyari. No? Right? But notice, guys, naging significant sila. Okay, plus the GPA. Plus the GPA. So si GRE talaga hindi siya significant. So hindi siya lalabas talaga sa equation natin. Okay, so interpretan natin to, guys. Let's interpret quickly. Okay, so first, let's learn how to predict this, no?
Sir, sorry.
Yes, sure.
Question ulit, sir. Bakit naging significant siya ngayon?
Yun nga ang nangyari ngayon kasi, that's a very good question. Bakit siya naging significant remember, ganito nangyari kasi, if you recall, di ba sabi natin si intercept, kahit na significant yan, hindi siya significant, pinapasok pa rin yan sa model sa prediction.
Yeah.
Di ba? Right? Yung mga to, guys, yung factor na yun, rank 1, rank 2, rank 3, rank 4, they're actually quote-unquote intercepts, no? They're intercepts of that specific factor ng rank 2, rank 3, rank 4. So when you remove the intercept, si rank 2 naging ano na siya, naging significant. In fact, I've seen some instances when hindi siya significant. Okay, not in this case. Sabi ko nga, I've seen some instances when tinanggal natin intercept, tapos yung factor, yung quote-unquote intercept ng factor, hindi siya significant. Still, when we interpret it, sinasama pa rin natin siya. Just to be consistent with the practice that yung intercept, kahit na significant yan, you also include that in the model. Okay, clear ba yun?
So parang basta as long as there are factors of the intercept, sinasama pa rin whether
Yes,
significant or not.
Yes, sinasama siya. No? Dito kasi tingnan nyo, close to point close to 10% yung yung ano nito. Tapos yung tinanggal ng intercept. Okay?
Less than pa.
Yung tinanggal ng intercept, remember pag nagtatanggal ka ng variable, pwedeng mabago yung pwedeng mabago yung mga significance. Parang yung nag-stepwise tayo dati, di ba?
Yeah.
Tingnan nyo, itong rank 2 naging highly significant na, di ba? Ibig sabihin nun, hindi na inagaw ng intercept yung ano ni rank 2, yung predictive power niya. That's what happened here. Kasi when you add a predictor, in that case, yung intercept, no? Tapos sinanggal natin siya. So, saan napunta ngayon yung predictive power ng intercept? It would have been distributed dito sa mga ranks, no? Rank 1, rank 2, rank 3, rank 4. Kaya si rank 2 naging significant na. So, very interesting guys yung question ni Celso. It's actually interesting kasi nakikita natin na kahit intercept lang yan, it will play a major role in affecting the other especially pag factor. No? Okay? So I hope, Celso, did that answer your question?
Si William yan, sir.
Si William ba?
Yes, sir.
Yes, sir. Ngayon, kailangan ilalagay mo talaga dapat lagi ito, no? Para nakikita ko kung sino nagtatanong. Okay, sige. Punta na tayo dito, no? We use the predict function, okay, in order to determine ano yung mga predictions natin. Okay? So let's first run this. Okay? So meron tayong predict dito, no? P1. Okay, let's click this. I-view na lang muna natin. View P1. Okay, so dito ko lang siya linagay sa console. P1 is an object, no? It's a vector, vector 325. Okay. So ano to? What's this? Point 21, what's that, guys? So that's the value of observation 1 when we use this this model. So that means negative 5.0095 and then plus 1.166 times GPA plus negative 0.57, depende kung rank 1, rank 2 siya, rank 3 or rank 4. Okay, let me illustrate that. No? We're going to illustrate that. Kasi si observation 1, rank siya? Rank 3, di ba? Tama ba, guys? Gentlemen, tama ba?
Observation, yes.
Observation number 1 is rank 3. So if we're going to use the model to predict whether observation 1 will be admitted or not, based on our model, okay, mangyayari sa model natin will be, so negative 5 plus 1.166 times whatever the GPA of GPA niya is 3.61, di ba? So ito yung tinatanong kanina ni William, do we substitute the values of the variables? Yes. So rank 2 will be 0. Tapos isasama natin itong negative 1.12. Bakit? Why, guys?
Kasi rank 3 yung
Yes,
school.
tama. Kasi si observation number 1, rank 3 siya, no? So, this will enter the picture. This will enter the model. Rank 4 will not, no? So, ang papasok yung -5 and then si GPA na 1.16, tapos this will not enter. The -1.12 will enter. The -1.53 will not. Okay, so let's formally do that. Okay, balikan ko lang tong P1 natin. So ito guys yung mga prediction. 0.21, 0.31, 0.72, 0.14, diba? Ito. What are these values? These are your log. Hindi, na-convert na to, no? Okay. So let's explain muna. Okay. So let's run natin ulit to guys. Yung run natin lahat ng to. Okay. What do we have here? Yung head guys will print the first six observations ng P1. Diba? So 0.213, 0.314, 0.72, which you can find here in P1. Yan. Sila yon, diba? First six lang kasi head, no? Yung head. And then yung head ng train data natin. Ito yung train data natin. If we compare guys, 0.213 admit 0, 0.314 admit niya 1, 0.723 admit niya 1. Okay, so hindi it does not tally guys, no? Hindi siya nagtatali whether admitted or not admitted. These are our predictions. These are the actual values. So we have to do something about it. Okay, what are we going to do? How do we now convert this one into this binary 0 or 1? Okay. Hindi nagra-run to, no? Pag inano na to, magra-run to. Pag ninate na natin. But this one, guys, is tino itong equation na to, ha? Y sub I is equal to log of P over 1 minus P times may ano dito, no? May equation dito. So, i-ano ko lang guys yung ano ko, yung i-on ko lang yung digital pen ko and then check lang natin sa okay guys, sa log odds ratio.
Ano, sir?
Familiar kayo sa log odds, ODDS. Log
Hindi, sir.
odds ratio.
Parang
Sige. Hindi. Sige. Explain ko lang ha. Kasi it's good for us to understand how this will be, itong ano na to, prediction na to, how this will be converted into admit or ano. Okay, but before we do that, mag-ano lang tayo guys, mag-sample lang tayo, no? Tingnan natin kung okay, I'm going to copy this. So ang papasok sa equation natin is this one. Tapos GRE will not enter. Si GPA papasok, di ba? Tapos si rank 3.
Rank 3.
Yan. So ang equation natin ngayon is -5.009, etc. And then plus yung sa GPA, di ba? So 1.66 times, what's the GPA of ano? GPA of observation number 1. GPA niya is
3.61.
yan, 3.61, di ba? Copy ko to, Control C, Control V, di ba? And then minus 1.12. Times 1 lang to, di ba? Times 1. Kasi rank 1 siya, di ba? Guys, correct?
Ay, rank 3.
Rank 3 is this one. Rank 3 pala, negative 1.12. No? Yun yun. Right?
Yes,
Tapos
sir.
bakit may times 1? Kasi papasok siya. No? The others will be times 0.
Ah, okay.
Diba? Or, pwedeng tanggalin naman to, of course, you know that. No? Pwedeng tanggalin yan. So this will be added to the coefficient. Diba? Okay, so let's run this. Ano yung value na to? Negative 1.92, no? Negative 1.92. So, bakit hindi siya, parang iba siya dun sa predicted value, ah. Saan ang galing itong 0.213 na to? But because ang predicted value, 2.21213, di ba? Pero when we apply the equation, you're getting negative 1.92. The reason, guys, is that this value is your log odds ratio. Log odds ratio yun, no? Okay, so siguro mabubuksan ko na ito. Let me open first my digital pen, okay? Tapos explain ko lang quickly sa sa Word. No? Just right here. Okay. Okay, review. Alright, di ba guys, equation natin, ba si admit, ito yung y natin, di ba? This is our dependent variable is equal to yung slope natin, diba? Plus B1 times your GPA, diba? Plus B2 times rank 2 plus B3 times rank 3 plus B4 times rank 4. Diba guys? I'm predicted that.
Yes, sir.
Okay? So this is our equation. Okay? So this is our y. Ito yung lumabas sa ating kanina negative 1.92. Yun, no? But the predicted value is different. It's 0.2. So saan ang galing yun? Now the difference is that itong y admit na to, guys, is not actually your probability. Rather, it's your log odds. No? Ano ibig sabihin ng log odds? So your y is equal to the log of the probability. No? Ano yung probability natin? It's the probability of being accepted over 1 minus p. Okay, ang tawag dito, guys, odds ratio. What are the odds ratio of being accepted? So p is the probability of being accepted over 1 minus p, the probability of being not accepted. So ang tawag doon, guys, odds. Kaya nga it's called log odds ratio. Okay, so the value that we're getting here, negative 1.92, is your log odds ratio. So we have to convert this, guys, into, we have to compute for P. Kasi yung P yung binibigay sa atin eh. Okay, let me show you, guys. Yung 0.213 na to, this is your probability of being accepted. Okay? When we apply the model itself, hindi siya yung P. It's the log odds ratio. Pause muna ako dun, guys. Clear ba yun?
Yes, sir.
Yes, sir.
Okay. So we have to convert, guys, yung ano. So first, ang gawin muna natin, i-convert natin tong ano. I-convert natin tong equation na to. Hanapin natin si P. Okay? So we have to get rid of log. Okay, a little arithmetic lang. So how do you do that, guys? We exponentiate both sides. No? From your previous math, I hope, no? Previous math kayo. How do we remove log? Exponentiate natin siya. E to the log. No? E to the log na will cancel yung log. So magiging P over 1 minus P na siya. Okay. Clear so far, gentlemen?
Yes, sir.
Okay. Na-meet nyo naman si ano, no? Si E, si exponential.
Oo, sir. Pero medyo matagal na.
Medyo matagal na. Anyway, yun ang rule, guys, ha. Para matanggal natin, kasi kailangan natin matanggal si log kasi gusto natin hanapin si P, no? So this is y is equal to log of P over 1 minus P. So we exponentiate both sides of the equation. E to the y is equal to, matatanggal na si log P over 1 minus P. Okay. Therefore, ano mangyayari nito? What will happen here?
Wait, no. Live over? Wait, I don't
Okay.
remember.
So ang gawin natin, sige, to easily compute for this, i-cross multiply. No? So this will become 1 minus P over P is equal to 1 over e to the y. Tama, guys? Cross multiply ko lang, itong denominator dito linagay ko sa kabila, tapos itong numerator linagay ko sa kabila, tapos itong e to the y linagay ko sa kabila, no? 1 over y. Clear? Tama?
Yes?
Ba't parang litong-litong? Honestly, guys, klaro ba yun?
Isa pa, sir. Isa pa.
Isa pa. Sige. Alright. Okay, dito ha. Kasi, di ba, ito, e to the y is equal to P over 1 minus P. So, ang gagawin ko, guys, i-multiply ko both sides by 1 minus P over P. Ganun, no? So, is equal to, i-multiply ko to ng 1 over P of 1 minus P over P. Siyempre, gagawin ko rin dito yun. Diba? So, anong nangyari? Nalipat lang yung 1 over P, 1 minus P over P sa kabila. Tama? Ang mangyayari dito, makakancel lahat to, di ba? Sulat ko dito, 1 minus P over P. Right? Tama? So, cancel lahat to. Tapos E over Y, multiply ko rin dito ng 1 over E over Y. Dito din 1 over E to the Y. So cancel dito, ang matitira mo sa kabila, 1 over E to the Y. Ito yon. This one. Guys, basic algebra.
Yes, sir.
Okay, so we can now solve for P. Ang gagawin natin, 1 over P minus 1. Distribute lang natin si P, no? Is equal to 1 over e to the y. Yan. Distribute ko lang si P to the numerator. Okay, therefore, what do we have now? I will need more sandali. Thinking na. Kumihirap po naka-think. So I'm now having problems. Go to the next one. Insert. Ang hirap mag-navigate ng ano, ng insert, isang ba, yung page ko dito. Insert new page. How do I insert a new page? Insert. Page break ko siya. Yan, okay? So, balik na ako sa thinking. Right, where's that pens? Okay, so ulitin ko lang ha. So, di ba yung kanina equation natin naging ganito na, no? So, 1 minus P over P is equal to 1 over e to the y. So, yung 1 over P minus P, just distribute the P. Maging 1 over P minus P over P, or 1. That's equal to 1 over e to the y. Okay, so this becomes 1 over P is equal to 1 over e to the y, transpose this plus 1. Gentlemen, nakakasunod?
Yes, sir.
Okay, so sorry to bother you with this. 1 over P is equal to, okay, combine natin to, over e to the y, and then so 1 plus e to the y. Right? Tama ba?
Yes.
Yes.
So therefore, P, yan, nasolve na natin si P. Yung reciprocal lang, P is equal to e to the y over 1 plus e to the y. There you go, guys. Okay? So yan guys yung ano, yan yung probability. Yung relationship ng ano ng log odds at saka ng probability is this one. Okay? So the value that we got a while ago, yung negative 1.92, that's not the probability, that's the log odds. So you have to convert the log odds into a probability. So sige, gawin natin. Saan na tayo dito? Okay. So therefore guys, okay, so magiging E to the Y, ito yung Y natin, no? Control C, Control V, another Control V. E to the Y divided by 1 plus okay. Take a look at that equation, guys. So that's your e to the y divided by 1 plus e to the y. Okay, so hindi ito guys yung value na gusto natin. Kasi log odds to eh. Kasi ganun talaga pag logistic regression guys. You use the function log odds. So what we want is this one. Yung probability, which is equal to e to the y in log odds divided by 1 plus e to the y. Okay, gentlemen, paki-run nga yan, paki-check kung ano yung value niyan.
One point, like 0.127.
0 point ano?
1274026.
127?
Yes.
Diba?
Wait. Ano ba ginawa ko?
Ito yun e to the y over 1 plus e to the y.
Yeah.
E to the y
1
divided
one.
by 1 plus e to the y.
Same.
Same.
0.127. Wait ha. Saan ako nagkamali dito? Mali ba tayo dito? 1.66 times GPA and then minus. Tama naman, di ba?
Yes, sir.
So, mali akong ginawa. Dapat siya 0.2 something, guys. Negative 5, okay, plus GPA 1.6 times ano natin, observation 1 is 3.61, tama. Tapos rank 3 siya. Rank 3. So ito yung papasok, negative 1.12531. So negative 1.92. Okay. Sige, guys, let's see. Kasi ginawa ko lang dito sa babayan. Let me check kung saan ako nagkamali. No? It should be 0.213. Okay, here below, yan. Ito yung ginawa natin, guys. No? Ito. ln of log of p over 1 minus p. So, negative 4 point, what negative? What negative 5? Negative 5 by intercept?
Yes, sir. Ay. Yes, negative 5.009514.
Oh, wait. Ha? Kasi dito sa baba, at negative 4 point, negative 4 point ano dito. Sige nga guys, sandali ha. I-run ulit natin yung set.seed. Baka set.seed tayo nagkaano. Okay, so let's run everything here. Let's run this. Tapos i-run na natin itong logistic na. This one.
Oh, wait lang.
And then, okay. All right. Apologies guys. Kasi ang dinidiscuss ko sa baba, ito. Yun, kaya pala nagkaiba guys. Kasi, ang ginamit natin guys, yung value ng intercept na it included the GRE as a predictor. We should remove that guys. Hindi siya significant, no? So, we have to, may apologies guys, no? Hindi natin rinan to, hindi pa natin rinaran to. Kaya pala iba yung
Oh.
okay? We have to delete that, no?
Okay.
So dito, rinan natin guys, GPA at saka si rank, but we deleted GRE because it was not significant. So when we run this, yun na, ito na yung equation natin. Okay, kaya pala, negative 4.72 na guys, no? Okay? Okay, so this is what we're what we're running now. Kasi yung rinan natin to guys. Okay, so let's run this again. Okay, na iba no, negative 0.28 yung first natin. So again, we check this guys using the first observation. 3.61 yung GPA, and then rank 3. And then if we follow this, ito na guys yung equation. This is now the equation. So look at this one. Okay, so let me copy this. Control C.
Sir.
Yes.
Ay, wait. Okay, gets. Never mind. Okay lang.
Sige, okay lang. Kahit gets mo na. Ano yung question mo sana?
No, I was looking at the equation lang and I was wondering ba't nandyan rank 2? Ayun pa, I forgot na it'll substitute 0 naman.
Yeah, yeah. I wrote that just to make sure that clear kung ano nangyayari, no? So si rank 2 sinama natin, pero times 0 yun. Si rank 1, si rank 3 times 1. And then si rank 4 times 0.
0.
Okay?
Hmm.
All right. And take note, guys, that this is for, ito yung base ng rank 1. And then, if you add this, negative 1 point, this will mean that rank 3 will be always 1.16 yung log edge niya less than this, no? Less than yung rank 1. Kasi nag-minus tayo sa intercept ng negative 4.72. Okay? Alright. So, yan yung equation natin. When we run natin to, no? Run natin siya, Control Enter. And then you get negative 0.93. Log adds to, di ba? So we can now convert this into a probability which is exponential of this, Control C, Control V, and then divided by, open parenthesis, exponential on 1 plus, or exponential plus 1. Exponential ng, yan. Okay? E to the y over 1 plus e to the y. So, guys, yung kaninang ginawa natin, tama yun, ha? Tama yung value na yun. Only that we were comparing it with a different, model. So if we enter this, yan, 2.28223, which is now the same as this one. Sana yung rinan natin dito. Sana yung predicted natin ito, no? Let me run this. Yan, 0.2822, no? 0.2822, medyo may may konting difference lang due to rounding off. 2822, 832, 2822, something. So the error was due to, the difference was due to rounding off. Pero maliit lang naman siya. Okay, let's pause for a while, guys. Any questions?
Wala pa naman, sir.
Sir, nagamit nyo na yung function na adds that ratio.
Hindi pa, no? Sige, gawin na nga natin yan. Tingnan natin, ha? Sige, I haven't tried that. I haven't done that. But, sige, tingnan natin. First, let's adds ratio. Tingnan natin. What does this do? Tapos, ano yung syntax niya? Okay. So, to me, ito yung mahirap, no? Odds ratio from the ORR. Odds ratio. ORR yung pangalan ng function. Parang iba siya, no? And it's from the Mosaic package. The function calculates the odds ratio and relative risk for a 2x2 contingent table. Okay, for each estimate. X should be a matrix, data frame, or table. Successes should be located in column 1 of X, and the treatment of interest should be located in row 2. Okay, so may mga kailangan, guys, no? So, I'm afraid, guys, we will not be able to use this now kasi may mga requirement tong function na to. Ang sabi niya, 2 columns dapat yung nakalagay.
Okay.
Successes should be located in column 1. Okay,
Sir, question.
Yes.
Sir, ano yung package ng odds ratio?
Mosaic.
Hindi pa ata. Kasi hindi pa ata na.
Dapat ilo-load natin yan. Install, and then install and then library natin bago natin magamit to. However, kailangan aaralin muna natin itong yung kasi tinan natin requirement, ha. Now, this is sino question, si William o si Celso?
Ako, sir, Celso.
Celso.
Celso, thank you for asking that, no? Now, this is akong ginagawa ko pag ganyan. Kunyari, I encounter a particular function na which I think I need, no? Titingnan ko kung ano yung ginagawa ng function na yan. And then I'll dig deeper. Pupunta ako dun sa package kasi yung sa documentation package niyon. Tapos usually kasi may mga example yan. Tingnan nga natin dito kung may example. Ito, guys, may example, no? Gawin natin to, let's see, for purposes of we might not be able to do this now dito sa data natin, pero Ako, bala kong gawin yan later on na lang. Ano? Pero tignan muna natin to. No? We have a matrix C, 14, 38, 51, 11. If you recall yung matrix, ano natin? N row, ibig sabihin to, two matrix 14, 38, tapos 51, 11. So sige, tignan muna natin to. Dito na natin gawin, Control C. O copy natin dito sa console. Okay, and then i-run natin. Let's see what the odds ratio will give us. Okay. Ayan, 14, then 38, 51, and then 11. Now, ano kaya itong 14, 38, then ito yung odds ratio niya. So, currently, para sa akin, I think I'll need more studying on what this means. No? Tapos ito naman, tingnan natin to.
Sir?
Yes, yes.
Pero we don't have to download the odds ratio, the mosaic now? Or should we download it now?
Wait. Dito kasi nag-run siya as an example. Kasi yung odds ratio, okay, so odds ratio, odds ratio. Ito yung ginamit natin, ano? Odds ratio. Nag-run siya dito. No? Ibig sabihin nun, ang alam ko guys, ang mosaic dapat i-load natin yan. So, nag-run ba sa inyo to, yung odds ratio na to?
Hindi po.
Hindi. Ibig sabihin guys, sa akin nag-run siya kasi naka-load na yata sa akin. No? Pero dapat library ko rin siya. So dapat hindi siya mag-run. Kung hindi nag-run sa inyo guys, then you have to install yung mosaic package. Sige nga, i-run nyo muna, install that packages and then library. Tapos try this example, yung M1. And while you're doing this, I'm going to try M2. I'm going to try M2, so here. It's complicated to M2. Control V. R5. 180. Yes?
Okay na ata, sir, I think.
Okay na?
I think 12.5. Yeah, okay na. Hindi, di-download ko, sir.
Yeah.
Tapos
In-install mo tapos
library
library.
was- Yeah.
Tapos rinan mo.
Yes,
A while ago, it did not, no?
No. Kahit yung ano, sir, kahit yung question mark odds ratio.
Ayaw.
hindi ko muna kanina.
Oo.
Ayaw. Kasi hindi naka-install. Okay, so I tried running M2. I tried running M2. Tapos, may ginawa siyang relative risk. Kasi dun sa odds ratio function, may required na relative risk to. A logical indicating whether the relative risk should be returned instead of the odds ratio. So, ito guys, never ko pa nagamit to, no, yung odds ratio na to. So, chi-square at saka Fisher test yung ginagamit niya. So, I cannot, sorry sir, hindi ko hindi ko masasagot muna yung yung question mo ngayon kung kung
Nice lang, sir.
kung ma-explain to ngayon. But I can promise, if you're interested, I'll look on this and then explain ko sa inyo next meeting. If you're still interested. Pero sige, hindi natin, no? Sulat ko lang dito na okay. All right. So sige, let's continue, no? Okay. Okay, now remember guys na yung probability na to hindi siya equal to 0 or 1. So kailangan i-convert natin siya. So itong 0.28 na to, ano ba to? 0 or 1? What do you think, guys? Si 0.29, 0 or 1 ba yan? Si 0.68. So ang ginagawang cut-off is 0.5. Any value below 0.5, 0 yon. Any value above 0.5, that would be 1. So si 0.28, okay, if you're going to convert this, so not admitted to, di ba? Right? So tama yung okay yung prediction niya. Pero kay observation number 2, 0.29 to 0.3, so dapat 0 to. Pero ang actual niya 1. So ito error na to, di ba? So may na-misclassify na dito. Dito naman sa third observation 0.68, 1, okay, tama. Sa number 4, 0.13, so dapat 0 to, pero 1. So here we can see, guys, na may mga mali at may mga tama. Well, we don't expect naman talaga na na 100% na talaga magkaka-error yan. Kasi this is a predictive modeling. But you get, guys, you understand what we're doing here?
Yes, sir.
Okay, so sige, tuloy natin to. Okay.
Pero sir, ba't ganun parang mas madami yung mali?
Well, pa lang yan, 325 observations to. So yung mga first tinitingnan natin. So tingnan natin, guys. Let's
Baka
see.
naglagay ng donations yung parents.
Ganun na? O, tingnan natin. Ito yung tinatanong nyo, no? Okay. Ito na, guys. How do we now convert into a 1 or a 0? So we're creating this object called pred1. Okay. If else yung gagamitin natin. Di ba?
Okay.
Yung P1.
Parang sa Excel, sir.
Oo. Yung maraming syntax naman sa Excel na pwede sa
Yung
so,
parang okay.
Oo. Itong P1, di ba? Ano itong P1? Ito yung predicted object natin. Diba yung mga probabilities. Diba yan, no? Yung 0.28 etc. So if it's greater than 0.5, okay,
1.
Give it 1. Otherwise,
Else 0.
O else
Para
0.
siyang if function.
Correct. And then, tingnan natin yung first 10 observations. No? Sige, run natin. Ayan, no? So, kinonvert na niya. 0, 0, 1, 0, 0, 0, 1. So, lahat ng mga probabilities natin were already converted into a 0 or a 1. Okay, guys?
Yes, sir.
Okay. Now, the good thing here. Tingnan natin kung ano yung mga tama at saka yung mali. No? Alright. First, let's create this confusion matrix. A confusion matrix tells us ano yung mga na-predict na 0 at saka na 1. Okay? And compare it with yung actual. Okay, let's see. So we're going to use this function called table. We're going to create this object tab1. Now, ano yung nasa y-axis? Yung predicted. Your predicted is equal to pred1. So may pangalan yung natin, yung axis predicted. Ito naman, actual, yung train, hindi yung buong train. Okay. Remember guys, yung train natin, asa yung si train. Yung train natin guys, apat na di ba? Apat na variables. Admit, GRE, GPA, and rank. Ang gusto lang natin guys, isa side by side na sa admit. Yun. Okay? So, si pred1 natin, isa lang naman yan di ba? Asan si pred1? Di pa yata natin na view. pred1. Okay, so si pred1, it's just a vector of 1. Ito lang yan. Yan, isa lang siya. No? So ang gagawin natin, isa side by side natin yung bilang ni pred1 at saka ni admit si train. Take note guys, si train train admit. Bakit natin kay train kino-compare? Kasi guys, dito nang galing yung model natin sa train data, di ba? Tapos itong pred1 na to, galing dun sa model ng train natin. Okay, so let's run this. Okay, and then print it. Yeah, this is now our confusion matrix. Okay, ano ibig sabihin nito? Predicted 0, actual 0. So, yung mga tamang prediction dito guys, itong diagonal. Yan, yung diagonal. So, dun sa hindi na-admit, guys, dun sa hindi na-admit, predict niya 208, hindi admitted. Predict niya, hindi na-admit, pero actually na-admit siya. Right? So, dun sa pag-predict ng sa prediction niya na hindi ma-admit, 73 mali. Diba? Doon sa predict naman niya na ma-admit, 15 yung mali. Right? 1 predicted, actual 1, tama, 29. No? Predict niya na 1 when in fact hindi, predict niya na admitted when in fact hindi siya na-admit. So 15 yung mali. Okay guys, clear?
Yes, sir.
Yes, sir.
So that's the confusion matrix. So yung tanong ni Celso, ang daming hindi pa kasi natin nakita yung buong yung buong data set. So this one now tells us ilan yung tama. So that's 237 at ilan? 237 out of 325 yung tama. Kasi 209 plus 29. Yung diagonal sa atin dito guys, ito yung tama. So una natin yung percentage ng tama. So we're just going to isum natin yung diagonals ng itong table na to, di ba? Tab 1 yan, di ba? So sum ng diagonals ng tab 1. What's tab 1 guys? Ito.
Yung ginawa natin.
Yes, oo. Isum natin diagonals divided by the sum of the total. Di ba? Take a look at that formula guys. Diba? It's a sum ng diagonals, so that's 208 plus 29 over the sum of tab 1, which are these 4 values. Okay, so tingnan natin ilan yung batting average natin dito. 72%. 73% correct observation, correct yung prediction. So ang mali, guys, 1 minus lang. So 72% correctly observed, 27% wrongly observed. Not observed, sorry. Correctly predicted, 27%, wrongly predicted. Okay, guys?
Yeah.
Questions?
Yes, sir.
Okay.
Wala naman.
Alright. Now, ang gawin natin, i-check natin dun sa test data natin, di ba? Kasi ito, dun sa natin, sa training data. Now, how does our model now work? If we're going to use it on an unobserved, unobserved. Ibig sabihin, hindi pa niya nakikita na data. How will it work? So, ganun din guys, we create this object P2, which is predict. Anong model ang gagamitin? Yung mod natin, okay, this time, predict yung model na mod on the testing data. And then the type is equal to, parang yung kanina, response lang din to, no? And then create this predict to, yun then if else, P2 greater than 0.5, 1, or 0. So what we were doing kanina dun sa training data, we're now doing it using the testing data. Okay, so sige, i-run natin to. Okay, so ito si predicted, no? 0, 0, 0, 1, 0. Dapat i-ano natin, no? Dali. Add si test. Pabaliktad ko. Nahingin sa ano. Uy, okay. I added this guys para by comparison. Okay, tingnan natin first 10 na lang. First 10 values. Run natin. Okay. So ito yung result sa sa model natin using the test data. 0001, 0001, and then yung fifth guys, mali tayo dito. 1. Yung sixth, mali din. Okay? Mali din. So may mga mali yung mga susunod, ano? Okay? Get so guys, parang ito din ginawa natin kanina, no? It's the same as what we did a while ago. We were comparing yung actual values. Okay? Ano ba si predicted? Predicted, guys, is now a vector of ones or zeros. That's from which predicted using the mod logistic regression natin on the test data. Okay? So,
Pero,
yes.
sir, walang lumabas sa akin dun sa head.
Sa head, sige nga, stop share ako. Paki-share nga.
Yes, sir.
You see?
So, sir, nung ni-run ko, ano lang, ganun lang. Yung Fred lang yung lumabas.
Yes. I-run mo yung buong code chunk na yan sa 124.
Ito, sir?
Yung buo. Sabay-sabay mo. Sige.
Ayun.
Ano yung nasa unang ano? Anong nasa unang box sa baba?
Here?
Yan, ano yan?
I don't know.
Click mo nga yan. Ayan, no? Pinag-iwalay.
Ay, ito, sir, ito yung, Fred.
Ayan yung Fred. Tapos yung head.
Pero,
Ayan
wala.
yung head. Ayan.
Ay, ito ba?
Oh, yan ang head.
Pero,
Sige, i-run mo yan sa console, yung head test. Sa console, yan. Sige. Control enter mo. Sige. Yan. Diba? Kasi that's our test data, diba?
Okay.
That's our test data. So, di ba ang test data natin, 75 lang siya. And it starts with yan, observation 5, 14.
Oh, okay.
Di ba?
I was wondering kasi why it didn't show up here sa console.
So, okay ang William?
So it's
Clear?
okay. Yes, sir.
Okay.
So dito lang siya pala.
Oo. Pinag-iwalay niya. No? Kasi sa akin, pinagsama niya eh.
Oh.
Mas magaling yung R mo.
Ay. Kasi yung latest version natin yung na-download namin nung first meeting.
Ganun? Oo. Baka, yeah, may mga ano kasi, may mga nuances yan. So, yeah, that's possible. Hindi ko pa yata na-update yung R ko.
Okay. Sige,
Okay?
I think
Sige.
Yeah.
Alright, sige. Share screen ulit ako ha.
Yes, sir.
Alright. So, tingnan natin guys kung ano yung create ulit tayo ng confusion matrix. So, I'm creating here a table. Ang predicted natin is equal to pred 2. Okay, so this is now the result of our prediction for the testing data. Okay, ang actual natin, of course, i-compare natin sa testing data. Okay, so let's run all of this together. Okay, yan. So for testing data, guys, predict niya na hindi ma-admit 48, actually hindi siya na-admit. Predict niya na hindi ma-admit, pero actually na-admit siya. So ang mali niya dito, 20. No? It predicted, the model predicted that the applicant will be admitted, but it was not admitted. He or she was not admitted, dalawa. Tapos predict niya na 1 and 1, no? 5. Okay? And then the percentage na correct na admit around 71%, which is good. It's not far from yung sa training data, no? 71, around 72% yung sa training data. Ito around 71%. So quite a good good prediction. Now, as to whether this is acceptable or not, yung 72%, it will really depend on the field of study. If this was in medicine, kunyari efficacy ng drugs, it will require a higher correct prediction rate. Imagine kung ang pinag-usapan natin yung efficacy ng drugs, no? Tapos ang kinalaman niya it's either death or life, di ba? So hindi pa pwede. Imagine 30% namamatay. Di ba? So it really depends. Hindi natin pwedeng sabi na walang standard na 80% okay yan. Hindi pa pwede. So it will really depend on the field of study. Okay. Now, lastly guys, itong simple lang na goodness of fit. If we run this, so chine-check lang, parang parang yung sa F-test, sa goodness of fit test, kung okay ba yung model natin. If overall, our model was able to predict yung whether ma-admit yung respondent or not, and makes use of the chi-square test. Hindi ko na muna i-describe to guys kasi pag ganito kasi we will go into the nitty-gritty of the chi-square test. But suffice it to say guys, tingnan na natin p-value. So if the p-value is less than 0.05, ibig sabihin overall our model is good. Overall our model was able to predict yung response variable natin. Okay?
Yes, sir.
All right. So I want to jump now to another method, guys. Siguro ang gagawin natin sa mga next meetings, magko-compare tayo, no? So your assignment will be to try to do this model, try to do this data yung admit using a different model. Tapos i-compare natin kung sino mas magaling, si GLM o itong next na titingnan natin, which is the decision tree. So kindly open the other yung isa pang RMD file that I shared with you. Okay, so this is now actually the first of so many other models that we're going to use. Okay, saan na siya? Yung pangalan nun?
Decision tree.
What's the name of the
Decision tree?
decision tree. Asan si decision tree ko?
Pang 5 ata yun, pang 6 sir, sa taas.
Ay, ito. Thank you. Yan. All right. So,
Sir?
yes?
Dun nung binuksan ko yung decision tree, may nakalagay dun sa ibabaw, package party and R part pilot required but are not installed. Should i-install mo namin?
Yeah, dito. Mag-i-install tayo nun, no? Yung part 2.
Okay.
Okay, sige. All right. So, decision tree, guys, this is one of the tools using machine learning. Now, ang problem na i-solve natin ngayon is similar to what we just discussed a while ago. Kasi yung kanina, di ba, ang inaano natin is whether a student or an applicant will be admitted or not. So that's logistic regression, di ba? Ito ganun din, logistic regression. Pero ibang method ang gagamitin natin. So, ang challenge sa inyo guys, itong data na to, subukan yung gawin ngayon dun sa GLM. Tapos, yung ginawa natin kanina sa GLM, subukan yung gawin sa decision tree. And see kung sino yung mas maganda, no? Sino yung mas nakapag-predict ng model. Okay?
Sir,
right.
question.
Yes.
Gagawin pa namin yung test and train or diretso na?
Dito magta-test and train din tayo. Oo.
I mean, dun sa assignment, sir.
Yes, oo.
Okay.
Kailangan natin malaman kung ilang parents yung kailangan mag-donate.
Ikaw, Celso, Okay, sige. All right. So let's first install the package party. You have to install that package first. Saka nyo ma-require. No? So na-install ko na siya. Require ko na lang. I'll give you a few seconds to install it. And the party package, guys, is not something that you do with your friends, no? Mahilig sa party dyan. Si William yata, panay ang party, no?
Hindi sir, hindi ako lumalabas ng bahay.
Oo nga sir. Siguro.
Hindi, before COVID.
Hindi
Documentation.
na nakapagsalita sir si William.
Oo nga eh. Hindi siya na makapag-deny.
Hindi niya kaya magsinungaling sir. So,
Oo nga.
totoo talaga.
Correct. Party. Kasi hindi. Mali. Double question mark ko pala pag package. Party.
Sir?
Yes?
Ano ulit yung first, yung RRT, ano?
Which one?
Yung anong RT?
Party.
Yung sabi niyo kanina.
Party?
Party.
Ay, party lang ba yun?
Party. Oh, party lang.
Ay, sorry. Okay, sorry.
Arty ka dyan.
Sorry na rin. Sorry. Hindi ko lang narinig. Okay na rin, sir. Sorry.
Okay. So, if we look at some information about the party package, it's for recursive partitioning. Okay, recursive partitioning siya. Tapos maraming maraming mga functionalities. Yan. Quite a lot of functionalities. Okay, we'll learn some of them now. No? Okay, so let's load first. We're going to make use of the cardio data set. Okay, of course, hindi nyo susundin kung nakalagay dito, no? Ano nyo na lang, since check natin kung ando doon pa rin yung ano nyo guys, if you're still yung working directory nyo, no, di ba? It should be there still. So paki-load guys yung cardio na dataset. Okay. Let me check the get working directory.
Ganun sir, nag-error.
Yung ano?
Kapag po
Which one?
yung kapag po ini-import.
Ini-import? Na-save yun na-save yun na yung cardio na na data dun sa ano? Bakit hindi nyo pa na-download?
Nag-download.
No, kasi I think pag diba kinopy yan yung file path ni sir.
Oo, wag ito.
Oo sir, pinalit niyo. Oh, wait lang.
Oh no.
You try na lang yung import dataset para
Wait, let me try. Oh, error din, no?
Error?
Cannot open the connection.
Kahit na i-import dataset mo lang?
Ano, yung sir, sinubukan ko lang yung sa yung sa code.
Dito sa code? Okay, saan ba yung ko? Nabago na naman yung yung working directory. Okay, kung nagkaka-problem sa code guys, import na lang natin. No? Let's decipher na lang kung bakit nagkaka-problem sa ganun.
Sir, tama ba yung import from text?
Oo, andali import dataset, pwedeng from base, no? Kasi CSV file yan, either base or text. Just use the base na lang. Base. And then you have to specify kung saan galing yung yung nasaan nakastore yung here. Sa akin, it's stored here. Ito yung cardio, no? Cardio CSV.
Sir, may window kasi nag-pop up nung na-select ko. Parang may gagalawin ba dun?
In-okay ko lang. Mukha naman siyang okay.
Ito to?
Oo.
Yan, oo. Ito.
Okay na siya, sir. Import
ito.
na agad.
Tapos just make sure na may heading, nakayas yung heading. Ha?
Okay.
Pag import data set, ito yung lalabas. It
Okay,
will give us a preview of the data set. Okay, then import. Okay, tapos ito yung ito yung code chunk niya. You can copy this. Okay, you can copy this and paste it dun sa dito sa code chunk natin dito. Okay, any questions? Clear so far?
Ano ulit yun, sir?
You can kasi di ba nag-import dataset tayo, di ba?
Yung ito. Okay.
Ito yun. Ito yung code na yun. So if I copy this, Control C, and then Control V. This was actually the code that was used in order to access this. Yung nasa console.
So you have to direct it pala to the file, sir?
Oo, kailangan i-direct mo sa file.
Okay, kasi yung sa code ko, yung ginawa ko is dinirect ko dun sa folder.
Dapat sa file. Kasi dapat i-click mo yung file eh.
Oo.
Tapos import mo siya.
Hindi, dun sa sir, sa code, yung import na na siya.
Sorry.
Siya. I mean, di ba dun sa left, yung sa code chunk,
yeah.
Parang hindi ko na pala nasama yung cardio.csv. Bale, parang nag-end lang siya dun sa folder.
Dito lang. Ay, hindi. Kailangan kasama to.
Kaya nung na-compare ko dun sa, yung, di ba, in-import from file natin, lumabas din yung tamang code. Kinumpare ko lang siya. Kaya pala dun nagkamali.
Wala yung cardio CSV.
Oo, wala yung cardio CSV.
Kailangan naka-specify what file your kasi until such time na CR, pwede namang hula kung ano yung gusto nating file.
Para siyang yung sa plot, yung ginawa natin, kailangan mong specify.
Oo.
Naliloko ko na si Celso.
Si William po yun.
Si William ba?
Yes, sir.
Yung huhulaan niya kung anong file lang. Hindi natin i-identify kung cardio ba siya o ano siya, o admit, o binary.
May napansin ako dun, sir, sa plot tsaka sa chart series. Yung difference niya. Di ba sa plot, kailangan pa nating i-identify kung ano yung gusto nating gamitin. Tapos sa chart series, hindi na.
Chart series kasi sa ano yun di ba? Sa quant mode yun. No?
Yes, sir. Yung sa plot kasi, ang ginagamit niya is line chart. So, kaya kailangan natin siyang i-identify. Pero pag chart series kasi, obviously, gamitin niya na agad yung open, high, low, close.
Yes. Oo. Magkaiba talaga. At saka, first, magkaibang package sila. Si plot, ancient na na function na yan. Doon nagsisimula si R, yun ang plotting talaga. Si chart series is a Johnny come lately, no? So, in-improve nila yan kasi si chart series is used in the context of stock prices. So, siyempre, yun ang context, yun ang so, pag ginamit natin chart series, automatic na yun na i-generate yung output without us adding more instructions. Okay, sige. So, meron na tayong cardio. If you take a look at the cardio dataset, 17 yung 17 yung variable. So medyo malaki-laki to. That's 2,126 observations. Ang variable of interest natin dito si NSP, no? Si NSP, I think in-explain ko ba dito sa ilalim? Okay.
Ayun, sir.
Sa ilalim ba na ano ko?
Nadaanan mo na ata, sir.
Sa
Daanan
30,
ko?
sir. NSP.
Yung 28.
Line 30.
Ah,
Ay,
okay.
27 pala.
Pero hindi ko na na-explain yung iba. No? Pero, sige. The variable of interest is N, which is normal state, S, which is suspect, P is pathologic. Sa heart condition to, no? Categorical variable that classifies into normal, suspect, or pathologic yung may tama yung puso, no? So first we have to convert CNSP as a factor. Kasi if you take a look at the natin structure ng cardio. Structure of cardio. Okay, CNSP is an integer, no? Integer siya. So gagamit apologies guys, no? Hindi nyo pala directly kagad magagamit tong data na to using GLM, no? Kasi ito tatlo eh. 1, 2, 3 siya. Kanina guys, yung ginamit natin admit, binomial yon, no? So hindi natin ibang kasi multinomial na to. Okay? So siguro next i-discuss ko how to do compare natin yung result dito at saka yung isang multinomial. Okay, kasi you cannot use binomial here because your variable of interest is tatlong factors, tatlong levels, 1, 2, 3, no? Normal state, suspect at saka pathologic. So ang assignment nun lang guys is use decision tree for admit data.
Oh, okay.
Okay, pero itong cardio hindi natin magagamit using the GLM, no? Okay, ibang method ang gagamitin natin doon. All right. So we have to convert NSP into a factor, no? So here we're creating another variable, NSPF, as factor ng NSP. So let's run this and take a look at the cardio data. So notice si cardio guys, meron na siyang NSPF dito sa dulo, no? Okay, kita nyo?
There.
Meron na siyang variable sa dulo, NSPF.
Yes.
Diba? And yung 212 na yan, that's not integer. Check natin structure dito. Check natin dito structure and then cardio. Okay, so NSPF factor siya, no? Although preserve pa rin natin NSP as integer. Okay, sige. Let's move on. As usual guys, magpa-partition tayo ng data. No? So let's set that seed ulit and then let's create an object called partition data sample.
Ay, sir, question.
Yes.
Doon sa, let's say sa assignment, yung set.seed, kailangan gawin ulit, no? For, let's say, the decision tree.
Yes, oo.
Same na yung gamitin natin. 1, 2, 3, 4.
1, 2, 3, 4 na lang din para.
Okay. Sige.
Okay, so you know this guys, we did this a while ago. So we're going to create two objects, we're going to create a vector PD, tapos may mga 1 or 2 yon. 80% 1, 20% nun 2. Okay? And then train, and then ito gagamitin natin yung word na validate for validation data or testing data, no problem. Binary lang natin. Okay, so let's run this. Run. Okay, so pinaano ko pala, print ko yung train at saka validate, dapat hindi na. Now take note guys, may train tayo dito. So ibig sabihin yung train data natin kanina, yung sa admit na supersede na yun. No? Okay, so yung train natin dito, 1718 observations. Kasi ito, 2126, nga natin 2126 times 80%. Hindi naman eksakto nangyayari, times 0.8. So 1,700, dito ang ginawa niya, 1,718. So medyo may dagdag siya, no? Hindi niya eksaktong ginawang 80%. 1718 Tama ba? Kasi si cardio natin has 2126 observation times 80 niyan is around 16. Dito, hindi niya eksaktong ginagawa na 80%, 20%. But there's a way, guys, to really peg it at 80%. Pero let's not discuss that now. All right. So, si train data natin, tingnan mo natin si in. View natin si in. Si in. Okay, yan, no? Ay, wait. Hindi pala, PD pala. No? Right? PD yung ginamit natin. Partition data. Sorry. Ayan, 2126. So, in-split na niya into ones and twos, no? Randomly. Okay. All right. So, ready na tayo, guys. Any questions?
Hey, sir.
Yes.
Sir, can
Yes.
I go to the bathroom lang?
Yeah, sure,
Wait.
sure.
Sorry.
We'll wait for you, William, ha? Oh, Celso, magkwento ka na muna.
Anong kwento, sir?
Pause recording muna natin. Remind mo ako, ha, na i-continue. Alright, sige. Go ahead.
Dun sa yung nag-create ako ng bagong, let's say, yung PD. Di ba before, tinanong ko yung parang, ba't hindi siya pinapakita lahat? Like, nasa isang row siya. I think, napansin ko why, is hindi niya ginagawang header yung first line.
Sige nga, tingnan natin. I'll stop share. I-share mo yung screen mo.
Sige, sir. Like yung dito, parang yung first PD na agad, hindi niya ginagawa yung parang sa
Walang table.
Dito 'di ba, yung LB is yung dito tas
Oo.
So ginagawa lang niya agad yung PD yung nawala. Wait lang. Oh no. Here. Parang ginagawang value yung PD. So,
so hindi niya hindi niya
pinapakita.
generate yung Balik ka nga doon sa code.
Parang where was that? Here.
Yan, tapos pareho naman tayo rin na code, di ba? I-run mo nga ulit yung PD line 38 ba yun?
Yes, sir.
Yan lang.
Ito lang?
Oo. Tapos, sa console nga, i-print mo yung
Ganon din, sir, kahit sa console mo.
Sige, view, PD. I-click mo yung PD.
Ito dito, sir?
Hindi, sa taas, dyan click mo nga yan.
Wala, sir.
Wala,
May ata eh. Wait lang.
Pwede mo siyang i-print lang, William. Print PD.
Kung print PD, dyan lang sa console mag-ano yan. Sige, i-print PD mo. Sa console lang siya mag-ano.
Capital P ba, sir? Or hindi?
Print, print. Tapos,
print.
pero dyan, sige, print PD. Dyan sa console lang siya mag-ano. Dyan lang siya mag-print.
Pero, wait, may nakita kasi akong...
Siyang Minesweeper.
Na sa game. Ano nakita mo? Hindi ko alam kung bakit ganyan. First kung ano yun first ko na na-encounter. First time ko encountering there.
Ay, hindi pala pwede header.
Pag head kasi lang, walang header na Pag head yung first 6 lang yan.
Kasi may nag-search ako dati, sabi nila header, dapat may header equals true. Para, ewan ko, di ko alam.
Sige.
Pero pag sinearch, wala naman lumalabas.
Subukan mo view muna. View tapos view PD tapos view tapos PD. Tapos tingnan mo kung pwede mo sa loob yan yung kama.
Sa loob?
Oo, pwede ba yun? Hindi, PD.
Hindi ko alam.
Kasi naman nga, header is equal to. Baka mag-error yan. Hindi, capital yan.
Okay. Error,
Walang
unused
ganun eh.
argument. Baka may ano.
Okay, sige. Anyway, tulungan din kita
Yeah.
hanapin yan, no? Kung bakit ganyan. Sige, okay lang naman yan.
Pero, I mean, yeah, okay naman siya, sir. Gumagana naman siya. Pero, pag renew ko lang kasi dito, hindi nakikita lang.
Oo nga.
Yun lang yung issue. Pero okay naman, gumagana naman siya.
Andyan yung may object, yun ang importante, andyan yung object na PD. I-click mo nga yung nasa, parang spreadsheet nasa dulo.
Lumalabas siya minsan eh.
Nasa dulo, William. Nasa script.
Ay, wait.
Nasa script window.
Wait,
lumalabas
sorry.
minsan yung
Sorry, where, sir?
You hover around that line yung sa PD.
Here?
Yan o, di ba may lumalabas na spreadsheet sa dulo? Sa left side. Gantin mo nga yan.
Wala, sir. Pinapasok niya lang dito sa gitna.
Okay. Napasok lang yun sa...
I-show attributes mo, William. O kaya yung nasa tabi, pwede. Yan.
Ay, new window siya eh.
Yan.
Wala.
Wala pa din.
Wala,
Wala. I don't know why.
Sige, decipher. I'll have to decipher that. Sige, iwanan mo natin, William, yan.
Sige, sir.
Let's continue, no? But I'll try to see also what's the matter with that.
Sige.
Share screen lang ako,
Yes, sir.
Okay. So we have now created, guys, two objects, no? Si train at saka si validate. Pareho lang yung sa kanina yan. So we will now mag-create tayo ng model where we're regressing NSPF on tatlong variables lang, si LB plus AC plus FM. So, predict natin yung kung magiging ano siya, N, S, or P using these three variables, using the data is equal to train. So here we're using the C3 function. So, i-ano nga natin, guys, classification tree function. Let's see what this does. C3 classification tree. So this is more powerful than actually, guys, yung logistic regression kanina, that's also a classification problem kasi gusto natin i-classify kung 0 or 1 siya. So sa mga machine learning tools ngayon, marami ng mga tools that we can use in order to classify. So ito, conditional inference trees, recursive partitioning for continuous, censored, ordered, nominal, multivariate. So ito kahit ano, no? Pwedeng continuous, pwedeng nominal, pwedeng ordered. Okay? So yung NSP natin, nominal lang siya, di ba? Nominal siya ng variables. But of course, kinonvert muna natin siya as factor. So this is the syntax. Okay, tapos may mga explanation dyan. So let's go here, guys. So we're regressing NSPF on this one. Data is equal to train. Okay, so let's run this first. So we created this object 3.1. Okay, tingnan natin, guys, kung ano yung 3.1. Okay, so it's a large binary tree object. No? If I click this, so marami siyang laman. Andyan yung data, andyan yung responses, andyan yung predict response, etc. William, nakita mo to?
Yes, sir. Lumabas naman sa akin.
Lumabas naman siya. Good. So yung result ng 3-1, guys, it's a list, guys. It's a binary tree, no? It's a binary tree object. Okay, so let's print muna yung 3.1. Let's print that. Okay. Do we have the same output, guys?
Parang.
Okay. Can you see this? Conditional inference tree with 10 terminal nodes. Okay, ano ibig sabihin nito? May 10 terminal nodes sa ilalim, sa baba, no? Ibig sabihin, yung mga nodes yan, pag sinabing terminal nodes, guys, dyan nag-e-end yung tree. Okay, response, NSPF, inputs natin si LB, ACFM, number of observations, 1718. Okay, so ano to, guys? Ano tong tree na to? What's this tree, guys? So medyo nakakalitong ano siya, no? Nakakalitong tingnan. Pero if we follow this, okay, itong unang ano natin, unang branch, sabi, if AC daw is less than this amount, then criterion 1. Ano ibig sabihin ng criterion 1 na yan? Tapos meron pa siyang sinasabi, if AC is less than this one, then pupunta tayo kay LB. If LB is less than 136, then punta ka naman kay AM. If AM is equal to 0.11898, then criterion 1. Okay, so ano ibig sabihin nito? It's quite difficult to appreciate what this means. But they do tell a story. No? They do tell a story. Tapos, it's better to, pag i-plot natin ngayon yan, ito, plot 3.1. Okay, let's see. Yan. Okay, run natin. Ito guys yung tinatawag natin na decision tree. No? I-zoom natin. You get the same answer, guys?
Yes, sir.
Yes, sir.
Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 nodes. No? 10 nodes. Ibig sabihin, 10 classifications to. No? Alright, let's see. Sabi dito, if yung AC daw is less than 0.01, if AC is less than 0.0011, punta ka dito. Okay? Tingnan mo yung LB. Tapos if LB is less than 136, sorry yung mga P dito probabilities, no? If AC is less than 0.001 yung value niya, then go to LB. Okay? And then if LB is less than 136, go to FM. If FM is less than 0.012, then dito siya. Ang prediction niya, category 1, si N. But remember, we're classifying into N, S, at saka P, di ba? So if you look at this plot, if you look at this path, guys, AC less than 0.001, then LB less than 136, FM less than 0.112, then it would be predicted to be N. Okay? Tapos may percentage, no? May percentage siya kung ilang percent mo N, ilang percent na S siya, or ilang percent na P siya. No? Dito, mas malaking percentage na ano na N siya. So yung mga predictions niya, guys, probabilities din. Again, the same path, and then if FM is greater than 0.112, dito siya, node 5 siya. And it's predicted to be practically 100% na pathologic siya. Ito yung P. Okay, so that's what this diagram does, no? Clear, guys? You have 10 terminals.
Yes, sir.
That allows us to predict any one of the responses. Okay, so you can follow this. Pwede nating sundan to just by looking at the observations. Subukan natin, guys, mag-isa tayong observation. Balikan natin yung data natin. So that's our cardio data. Okay. Tapos mas maganda, guys, mag-create tayo ng ano, no? Nag-create sana tayo ng isang object na ang doon lang yung LB, yung AC at saka yung FM. Para mas madaling i-check. Ito AC, FM at saka yung isa versus LB. LB is LB ba yan?
UC yata. Yung hindi ginamit, sir?
Oo. AC, FM, at saka ano yung isa?
ACFMLB.
AC,
FM and LB.
AC, at itong first three pala. Andito pala. Okay. So, compare lang natin guys sa sa una, no? Saan yung plot natin? Okay. Let's see guys. AC daw. If AC is less than 0.001. So for the first observation, AC is less than 0.001, di ba?
Yes, sir.
Punta tayo kay LB. LB is, if LB is less than 136, then punta tayo kay FM. And then if FM is less than 0.12, then ang prediction niya, normal to. So itong unang observation, normal yan. That's normal. Ang prediction niya. Okay, let's take a look at observation number 2. Okay, so AC less than 0.001, 0.001, hindi, di ba?
More than.
More than. So pupunta tayo dito. So dito, is AC less than 0.002 or greater than 0.002? Kasi 0.006 siya eh. So dito siya pupunta, di ba?
Yes.
Right? Then we look at LB. Is LB less than or equal to 136? Yes or no?
Less than. No.
Yes, so pupunta tayo dito, no?
Less than.
Oo, less than 136.
Okay. Yeah.
And then is FM less than 0.0012?
Ano yung 0.003 ba yun?
0.0012. Okay, second observation ha. Diba? Yes, diba? Ito, si FM.
Yes.
Observation number 2 tinignan natin. Oo. Less than 0.002. So, ano rin siya? Normal din. No? Normal din ang prediction sa kanya for observation number 2. So, our model, C3, the C3 function from the party package, was able to come up with a decision tree that will help predict whether a certain observation will be normal, suspect, or pathologic. So ito yung model na to. Yes.
Question up. So the package, the party package determines everything already.
Oh, using the decision tree methodology.
Yeah. So it determined na parang insignificant yung UC. Ganun ba? Yung
no. As an example lang, hindi natin ginamit yung the other variables. Of course, we can use that. No? Pwede rin magamit. No? As an example lang to. No?
Oh, because we specified LBACFM.
Correct. Kasi kung gagamitin natin iba, of course, may iba yung model natin. Sige, try natin ha. Isama natin guys si DL, kunyari, no? Si UC. just for purposes of discussion. If we add sino to isa plus UC plus DL ba yun? Plus DL. Okay. Dagdagan lang natin ng dalawa. Just to bring home the point, no? So let's call it still 3-1. Okay. And then i-plot na lang natin, plot. Okay. So you now have several several terminal nodes na. Tapos papasok talaga si DL at si UC pumasok. So mas complex na siya, no? Mas complex na yung model na yun. I deliberately did not include them just for us to understand what's happening. Of course, guys, pag tayo yung gumagawa nito, dapat naiintindihan natin, mayroon tayong idea kung relevant yung mga factors na yan. Perhaps, nag-regression muna tayo siguro, tinignan natin kung significant ba yung mga variables na yan. Okay? And then we use decision tree to look at another model of prediction. If you take a look at this, may ano na siya dito, may dinagdag natin, si UC at saka si DL. Pumasok na siya sa pag-determine kung magiging N ba siya, S o P. Okay, but you can see here, very comprehensive, guys, no? Very comprehensive.
Yes, sir.
It tells us the path, no? Okay, so babalikan ko lang, guys, so tatanggalin ko muna itong dinagdag natin kanina. Okay? And then just to limit our discussion, just to na-print yung 3. Okay. Tapos ito, guys, you can use this plot 3.1 type is equal to simple. If we run that, okay. So ito, guys, hindi yung histogram pinapakita, no? Pinapakita dito yung values itself. So for example, ito yung path kanina, no? And the probability that it will be N is equal to 71%. The probability that it will be S is 9%. And the probability that it will be pathologic is 10%. Okay, kanina kasi ang pinakita, di ba, yung mga histogram na, yung histogram na.
Yes, sir.
Okay, and then here, 405 of the observations are inside this prediction node. Okay, tapos yung iba din, okay, andun. So na-predict niya, no? Na-predict niya kung magiging N, S, or P ba siya using this algorithm called decision tree. Okay, so all right. Then actually, guys, mako-control natin yung we can control the number of nodes. So there are several ways to do this. So ito, for example, I'm calling this object 3.1a. Ganun pa rin C3, ganun pa rin yung model natin based on the train dataset pa rin. And then we can use this controls is equal to CT control. Okay, so we can use, may mga several minimum criterion is equal to 0.9 and minimum split is equal to 50. Okay, ano ba nangyari dito, guys, kanina? Dito kasi meron tayong mga may mga nodes tayo dito na 12 lang yung laman, di ba? Tingnan nyo, ito, guys, di ba? Ito may 28, ito may 314. So yung ibang nodes, guys, konti lang yung laman. So dito we can say that dapat pag mag-split siya, dapat minimum 50. Yun lang ibig sabihin nito. So this will refine our model a bit. Okay, kasi dito 10 yung natin, di ba? 10 yung nodes natin. When you refine it, depending on how you refine it, it can compress your model a bit. Okay, so i-run natin to. Let's run this 3.1. Okay, diretso ko na sa plot simple, guys, ha. Diretso ko na dito sa simple. And then, so let's compare. What do you notice?
Nag-error
1,
yung
2,
sa akin,
3,
sir.
4, 5, 6, 7.
Akin din, sir.
Nag-error?
Yes, sir. Wala daw C3.
Walang C3. Eh,
Yes,
galing sa party package yan. O sige, sa akin kasi okay eh. Ilagay nyo rin party. Sige, para party. And let's see if it runs.
okay.
Nag-run na?
Wait lang. Colon yan, sir, no? Colon.
Yes.
Ayaw pa din, sir.
Wala pa rin.
Sige nga, paki-share na. Stop share ako.
Error in...
Stop paki-share na.
Ay, Wait lang. Chrome ata yung na-share mo.
Oo nga. And sir.
I-ano mo yung arm mo. Yan. Could not find C3 control. Why? Check natin ha. Charles, pa-share ulit ako ha.
Is
First, let's look at C3. Kasi dito makikita natin na pwede yung C3 control. Ito guys, tingnan nyo to. Kita nyo?
yan, may lumabas sa akin na ganyan, sir.
Ayan, controls is equal to C3 control. So pwede siya. Yan. That should work. Tapos may mga examples sa baba. You can try to look at that, no? Ayaw pa rin sa inyo, guys.
Ayaw pa din, sir.
Ayaw pa rin. Sige, i-leave muna natin yan, ha? Pero you notice, guys, as I showed you guys, pwedeng controls, no? Which can be obtained using C3 underscore control. Okay. Nag-work sa akin. Sige, iwanan ko na muna yan. Okay? So, hindi ko alam kung bakit hindi siya nag-run.
Wait, patingin na lang.
Parang nakita ko na.
Bakit?
Wait lang, sir. Try ko.
Sige.
Sir, scroll up lang. Sorry.
Scroll up.
Ayun na, down. Dun sa code mo mismo.
Galing ko na yung yung output. This one?
Yes, sir.
Hindi.
3.1a. Pero gumana naman yung C3 kanina eh. Dun sa yung sa 3.1.
Iran nyo nga ulit yung
Yung kanina?
Iran nyo nga ulit yung 3.1. Bago naman.
Hindi na gumana.
Yung yung 3.1.
Oo.
Tanggalin nyo ulit pinanggal nyo yung dalawang variables na pinasok natin. LB plus AC plus FN.
Yes, sir. Ba't ganun?
Ayan, gumana na, sir.
Dapat nag-run yan.
Tinanggal ko yung control.
Which one? Itong controls?
Yes, sir. Yung controls lang na word. Yung dalawa, yung controls tsaka control. C3 lang yung nilagay ko. Kasi yung sa taas, C3 lang ang ginamit natin eh. Walang nakalagay na control. Try mo i-remove.
Sige.
Mo yung controls. Feeling ko kasi dahil hindi siya magkamuka. Doon kasi sa taas C3 lang tapos dito C3 control.
Pero ibang model na to cells. We're now creating a different model, 0.18 no? So wala siyang kinalaman dun sa taas. Kasi sa taas 3.1 lang. Tapos walang controls to. Tapos pag tingnan nyo guys yung literature niya, C3, pwede ka maglagay talaga ng controls. No? In fact, ito yung syntax niya, C3. Open parenthesis. Inside the C3, you can have this. No? Formula, data, subset, weights, then controls is equal to C control, C3 control. Kita nyo guys? So this should work. inside the C3 function, you have controls is equal to.
Sir, patingin ako nung ano, results na pag niran mo.
Sige ha. 3.1a. Okay, ito na muna. 3.1a muna. So, ito, if I click this, so ito si 3.1a.
Error level. Ayun.
Tapos, if I plot, no? Siya. Ito, nag-increase nga yung terminal nodes ko, no? Okay, my terminal nodes increased. Kanina, kanina 10 lang.
Ay, mali. Wait. Oops. Oh, gumana na sa akin, sir.
Gumana na?
Wait lang. Parang, can I see? What's it supposed to look like?
Wait ha. Which one?
Nagana.
Itong ano?
Yung 3.1, yung 1A.
Okay, I'm going to plot the simple ha.
Yun yung 1A, sir?
Ito.
Sige, wait. Try ko din. Ay, gumana na ata.
Yan.
Hindi ko na library yung party.
Oo nga.
Pero ba't gumana kanina? Ba't nag-run kanina?
Oo nga.
Kasi
Hindi ko alam.
at the onset, yung 3.1 na gumana yung 3.1 mo?
Yes, sir.
Kasi hindi gagana yan kung hindi pa, wala ka pang library.
I don't know why. Pero ni-library ko lang kasi yung party, tapos sinubukan ko ulit, gumana na.
Okay. Weird, no? Kasi kanina, nag-run yung unang model natin, di ba?
Yes, sir.
If that run, ibig sabihin, naka-load na yung library. Naka-load na si party package. Tapos huli na natin yung 1A, hindi nag-run. Tapos reload mo si library, saka siya nag-run.
Yes, sir.
That's quite weird, no? Anyway, at least nag-run na. Ikaw, Sels, nag-run na?
Yes, sir.
Nag-run na sa'yo. Okay. So, notice guys, makokontrol natin yung output sa ito. Naging 12 yung output. Naging 12 siya. Kanina 10 eh. So, ibig sabihin, mas grabe yung mas ano yung model na to, mas let's say mas
Complex.
Yeah, mas complex kasi mas maraming terminal nodes. You can of course relax it a bit by natin. So here another example, 3.1b, ang minimum criterion naman is 0.999 ginawa ko dito. Okay, so let's run this. 3.1b. Tapos, isa ko lang. Print, ilan yung maging nodes ko dito?
5?
Mas kumonte.
4 pala, 4.
Kumonte na lang yung terminal nodes, no? Kasi inanuhan ko yung minimum criterion eh. 0.9999. Ibig sabihin, mag-aano muna siya, mag-split siya kung ganito yung probability, no? So this is more relaxed, no? So pag pinat natin yung 3.1b sample, 1b simple. Okay, mas ano lang to. Tingnan niyo yung plot niya. Okay, so 4 na lang yung terminal nodes natin. Kasi guys, pag mataas yung probability, ibig sabihin, mas maraming papasok doon ng mga possible na values. Okay, so you see here guys, 4 na lang yung natin. So this is quite flexible yung model na to kasi it will depend on how let's say how complicated you would want your model to be. Okay, so and now we can now predict just like dun sa kanina. Pwede tayo makapag-predict. Dito din, pwede tayo makapag-predict. So we're going to use here, just to make the example simple, gagamitin natin guys, P1 and then P1 train, no? P1 train ipipredict natin si 3.1b, itong model na to, no? Okay, then let's see. All right. Hindi. Mali. Head ng train. Okay. What could have been better here, guys? What could have been better is we create an object na ang laman lang LBACFM. Kasi kung hindi naman natin gagamitin ibang variables, okay, parang it gets in the way. If we're not going to use them for our specific model, then we could have created an object muna na ang laman lang LBAC and FM. Okay, and you know how to do that, di ba, guys? Paano nyo gagawin yun? Kunyari, ang gusto nyo lang LBACFM. Diba? Kunyari, let's say that one, and then, yung gagawin natin, that, and then brackets, di ba? Square brackets, and then, lahat ng rows, and then CC, ang laman lang ni CC, no? C, LB, AC, or C, or pwedeng 1 to 3. Yung natin yung first three. Yung first three lang, no? All the rows, all the observations. And that one, natin. Diba? Ay, bakit si admit? Ay, wait. Kasi, mali. Kasi yung object natin is mali yung object natin. Ano ba ginamit natin? Sa taas? Cardio pala. Okay, that one, ulitin ko, that one, okay, is that, and then, cardio 1, cardio 1, cardio, overloads, and view. Okay. Yan, ba? Okay, so pag mag-generate na tayo nito, it's easier to control, no? It's easier to work with this. Kasi kapag kunyari nagpe-predict na tayo, hindi na sinasama ibang variables na hindi naman natin kailangan. Okay, so tingnan natin guys kung ano yung batting average sa model natin. 3.1 model natin. So here, we're using 3.1b guys, yung apat lang apat lang di ba yung terminal nodes natin?
Yes.
Hello, follow guys?
Yes, sir.
Yes, sir.
Okay, so we're dapat ito lang to. Head ng P1P. Head ng P1P at saka head ng okay, ito yung mga natin guys, yung mga prediction for the first 6. So this is, yung one natin? Normal. Okay, pero pag tingnan natin guys yung head ni train, no? Train data natin. Okay, head ni train guys. Asa na si NSPF natin dito? 21113, no? Yung first 6, 21113. Pero ang prediction natin kanina, di ba? 111 something, di ba? 11 yata lahat. Control enter. Ayan, yung prediction natin lahat sa normal, pero yung actual suspect 21113. So may siyempre may error may mga na-misclassify tayo. So once again guys, create tayo ng table comparing the predicted value tab 1A Ito guys, ang predict natin, yung 1A.
Yes, sir.
Okay. 1A yung, so, what will happen here guys? Dito, i-predict natin si 1A. Ang kanina predict natin si 1B. No? Tapos dito, magpapakreate tayo ng confusion matrix for 1A. Si 1A yung una, di ba? Hindi, yung pangalawa. Tama ba? Ano yung si 1A, guys?
Yung first.
Yung
Yung
first
second
kasi,
natin is
yung first natin, 0.1.
Ay, 1. Oh, sorry.
Ito yung 10 terminal nodes. Si 1A natin, 12
right.
terminal nodes. No? Tapos si B yung 4 lang. Okay, compare lang natin guys yung kung sino mas may power na mag-predict. Alright, so I'll start with 1A. Okay, I'll run this. Parang yung kanina lang to. Okay, so si 1A guys, 82% yung correct prediction niya, no? So ito yung confusion matrix niya, no? So 1, 3, 0, 4, 95 and 11, those are the correct predictions. So may mga misclassifications siya. 17% or approximately 18%. So si 1B, yung 4 lang na terminal nodes. Okay, 80%. So mas mataas guys mas mataas yung mas maraming terminal nodes, no? 82% siya. Si 80% lang. Okay? Clear yung guys? Clear?
Yes, sir.
Okay.
Yes,
All right.
sir.
Then okay, ito naman guys. Ito natin i-print, no? Hindi ko na i-print to. Ito naman, anong ginagawa natin? Predict natin guys using this time using what? The validation. The validation data. Okay, so pwede din natin i-predict using 1.a validate. Okay, and then if you take a look at this, itong pangalawa guys, ang bibigay niya yung probabilities, not yung 1, 2, 3. Bibigay niya yung probabilities dito. So I'm going to run this. Okay, hindi ko na pina-generate, no? Hindi ko na pina-print. Okay, tingnan ko lang yung classification guys. So dito, this is now my validation data, no? Tingnan natin kung how well our model 1A was able to predict yung validation data natin. Okay, run natin to. Oops, may mali ako. Ano pa hindi ko na-run? Baka may hindi pa ako na-run dito. Na-run ko na si 1AV, na-run ko na ba? One V. Okay na. So 1V. Okay, medyo nagkaka-error ako dito. Wait na. Okay, anong ginagawa ko dito, guys? I'm now predicting using the validate, no? Validate. Actual, validate, and SPF. Okay, table. Predicted is equal to P1V, which is this one. Ayun. Ayan, guys. All right. Sorry So, dapat ito gawin nating ibang pareho kasi. .p na lang to. Okay. Malapit na tayo, guys. So ito guys, I'm creating an object called predict1 for the validate, and we're predicting using the model 3.1a and using the validate dataset. Di ba yung validate natin, ito yung test dataset natin. Pakibago na lang guys yung pangalan ng object na to kasi nagka-problema tayo sa babae. Okay, so lagyan nyo lang dito .p. Ang kaiba niya, ito, ang tinatype nito, probabilities, not the 1, 2, 3. Okay, so let me just illustrate head. Mabilis yata pag-explain ko, no? Mabilis na yung pag-explain ko. Okay, ito yung head, guys. Hello, can you hear me?
Yes, sir.
Yes, sir.
Okay, so itong object na itong 1V, we're now using the validate dataset para i-predict using the 3.1a model, yung 12 yung 12 yung terminal nodes. And ito yung mga prediction siya, 1, 1, 1, 1, 3. And if we compare this with yung head ng test, no? At validate. Okay. Saan natin to? Okay. So we're predicting the test data set na, no? 1, 1, 1, 1, 3. And then i-compare natin yung ano niya, yung actual 1, 1, 1, 3, 3. So medyo, of course, may expected yan na may misclassification. No? Okay. Pag ito naman kasi ilagay natin, type is equal to probabilities, guys. Okay. And then, lagyan natin dito head P1V.P. I just want to distinguish ano yung difference nito. P1V.P. Okay, close. Enter. Oops. Mali. Saan siya? P1V.P. I-run ko muna ito. Run. And then yung head niya. Okay. Notice guys, anong binigay niya? Ang binigay yung mga probabilities o yung mga percentage. Kung n ba, ano yung percentage na n siya, ano yung percentage na s siya, ano yung percentage na p siya. Okay, yung isa naman, yung walang type is equal to probabilities, ang binigyan niya yung classification mismo. Kaya 1 yung una kasi mataas yung probability na 1 siya. Okay guys, clear?
Yes, sir.
Ha? Sorry, may question?
Wala, sir.
Wala. Okay, sige. Tapusin natin to kasi alam kong gutom na kayo. No? Okay, so ito naman guys, gagawin natin ng classification tree ulit. Okay, si predicted natin ng P1V at saka yung actual ng validate na NSPF. No? I-print natin yung confusion matrix tapos kunin natin yung percentage ng correct at saka wrong. Run natin to. Alright. 79.9% at saka 20%. So around 80% guys ang correctly predicted, okay, using the 1A itong 1A model natin, di ba? Okay, and around 20% yung mispredicted. Anong difference siya kanina? Halos pareho guys, no? 80%. 82 pala yung using yung 1A model natin. So practically guys, okay yung model natin kasi it was also able to predict 80% using new data. Okay? All right. So let me stop there guys kasi ito another package. And I want you now to compare yung party at saka yung R part, no? Okay, so please run this. Okay, tingnan niyo kung ano yung difference nila. Okay, may konting notes naman dito. Okay, R part is also a good, konti na lang naman guys, konti na lang naman yung, pero okay ba guys, tapusin na lang natin to kasi konti na lang eh.
Yes, sir.
Yes, sir.
Okay, so i-ano natin, i-load nyo guys si R part at saka si R part.plot. These are two different packages. Sige, paki-load na guys. Install that packages muna.
Okay na sa akin, sir.
Sa akin din.
Okay, good. Okay. So, this time guys, 3.2 na tayo, no? R part naman ang gagawin natin, Kanina C3 from the party package. So, let's run this. Itong dalawang to. 3, 2. Okay? So, tingnan nyo guys. Alright, medyo iba yung pagkaano niya, no? Medyo iba yung pagkabigay niya, no? ng output. Okay? May differences sila. Okay, I'll leave you guys to explore what this means, but you can easily understand this if you plot. Our part dot plot 3, 2. Let's plot that. Okay. So in terms of plotting the mas maganda si R part, di ba? Mas mas clear, okay?
May color.
Oh, may color pa, no? Tsaka mas clear yung kita din yung probabilities. Kita din guys dito yung percentage, no? Okay? Percentage to ng anong percentage ito, guys? 58%, 24, 1, 6, 6, 5, 1, 24. Is this the total percentage ng ano? Hindi. Percentage to ng bawat branch, no? Okay, so itong branch na to, 58% will go here. Yeah. Okay.
42 there.
Correct. Kasi ito ang tinatanong, AC. Is it less than 0.00083 something, no?
So, bale sir, each succeeding one has total to the preceding one. So like iba yung 24, like yung 24 tsaka 18 dun sa second, dapat magto-total sa 42.
Correct, correct. Kasi itong 42 na to, broken down into 24 tsaka 18 dito. Correct. So itong 24 na to, broken down into 24 and 1. Kasi naka-round lang kasi yan. 6 and 6 and then 5 and 1. Okay? So ito naman yung R part, no? Which is another package. Okay? And then dito guys, just pwede nating may variation ng R part plot by extra 1, 2, 3, 4. Okay, so just tingnan nyo lang guys kung ano yung difference. You'll be sinabi ko naman guys kung ano yung differences nila, no? Okay, and then sa prediction natin, ito P2. Okay, so let's plot this. Ayan, so ito yung prediction niya. Observation 1, 2, 3, 4, 5, 6. Okay, 1, 1, 1, 1, 1, 1, etc. Ito yung prediction niya. No? Prediction niya, and then what's important is yung confusion matrix. Okay, ito yung confusion matrix niya. And then we can see ilan yung correctly predicted. Dito sa R part na ginamit, mas mataas yung prediction niya. No? Iba kasi yung algorithm yan. So 83 but hindi masyadong nagkakalayo. 83 and 17%. Kanina 82 something. Okay, ito naman kung gagamitin natin sa validate data. Validate data. Okay, ito yung mga prediction and then let's see ilang niya. Okay, 80 and 19. So hindi pa siya nagkakalayo guys si C3 at saka si R part, no? Practically the same. 1% lang naman yung difference. All right. So with that guys, that ends our first discussion towards ML. Sabi kanina ni Celso, akala niya itong subject na to is more of yung paggamit ng software sa trading, no? Kunyari, sa pag-create ng portfolio, etc. We will actually go there. Inuna ko na muna itong machine learning. Kasi nag-i-evolve din itong subject na to. Dati nga, panay Excel lang to eh. But I found Excel to be really disadvantageous to students kasi hindi siya ganun ka-robust, hindi siya ganun ka-powerful as R. Okay? Right. So sige, end ko na tong discussion natin. Okay, I hope you learned something guys today.
Yes.